This one's got a fun story behind it. MSI sent it with a note. Hey, level 1 gang, congratulations on 300K. Here's to a million. MSI. Aw, thanks. Thanks, MSI. This is the GeForce RTX 3090. It's got 24 gigs of VRAM. 24 gigs of VRAM kind of excites me for content creation and some other stuff, but we're going to do some full benchmarks on this. We also reviewed the MSI Suprim X 3080, but we're also going to take a look at the Suprim X 3090. Now, I'm not expecting wildly, dramatically different gaming performance on the RTX 3090, but for content creation and some types of productivity, but not all types of productivity, it can make a big difference having 24 gigs of VRAM. And also, things like how many cats per second we can get on the inference benchmarks, new stuff. So when Jensen debuted this, he called it the BF GPU. And I can tell you right now, it certainly is. Thanks again, MSI. We passed a little bit of a milestone. I mean, I don't know. For the Fringe Aspie channel, I guess we're doing pretty good. This unboxing experience seems oddly familiar. So we've got the welcome card. Its features, the core pipe. It's a copper base plate, dual BIOS switch, airflow control, close quarters heat pipe and heatsink, anti-bending strap, twin Frozer 2S thermal design, MSI Dragon Center, Mystic Light, and Afterburner. And I really like Afterburner. 2-ounce copper PCB. It's got some extra fuses just in case. Double ball bearing fans. There's a lot to like about this card. It is serious business. Here's our Supreme mouse mat, Suprim X. This is again our card holder leg thingy. So the idea with this is the card is so heavy, you can make it a little bit more safe to transport because you can put this inside your case and support, oh, I've got it upside down, and support your card. So your card will be in your case, like here on your motherboard, and this you can position however you want so that the back end of the card is supported because it's very big and heavy. All right, first off, because I know 50 of you are going to obsess about it endlessly, the capacitor configuration. Mostly the little tiny caps that are everything's surface mount. And then we've got two of the other kind of caps, which again turned out to be a driver issue, not a board configuration issue. But if you have more of the right kind of capacitor, it can make a difference in terms of overclocking. Now, our fan configuration here and the height of the card. This is an enormous card. You're gonna wanna double check your case compatibility because it's definitely not gonna work. Oh, that's so nice. In every case. See what I meant, what I did there? Every case. As in, kind of make a mistake with the case. This Surface Book, the interface between the screen and the keyboard, that's actually PCI Express by 4. I wonder what would happen if we shoved this thing into a Surface Book with a PCI Express 3.0 by 4 interface. That's gonna have to be an experiment for another day. All right, so by default, right out of the box, the BIOS switch located here comes in silent mode. I'm just gonna go ahead and switch that to gaming. So now it's in gaming mode. We've also got 3 8-pin power connectors here. As if you've watched some of my other videos, I kind of explain this. It's not really that these cards need 3 8-pin power connections. It's that some people are in the unfortunate position of having a power supply where you've got one cable that has 2 plugs for GPUs on it. And so probably one of the top things that happens in GPU support is people will have trouble with that because these GPUs will use a lot of power momentarily. The momentary power draw is sort of far above that TGP of 350 watts. We've seen from other cards that the 3090 in general, even Nvidia's version of the 3090, can shoot 450 watts, 500 watts in terms of momentary peak draw, enough to trip a power supply that's 750, 850 watts because the power supply thinks a dead short has occurred and shuts down. So this sort of mitigates that, but not in the way that you might expect. I mean, having 3 sets of conductors to deliver power, yes, you're gonna have less chance of a voltage drop with that. But really what this is doing is ensuring that there's at least 2 home runs all the way back to the power supply, that you're not using one cable with shared connectors or one cable that has 2 connections. So there's really only one physical extra power cable powering the GPU. If you did it just right, 2 physical power cables would be just right. If your power supply has them, you can run 3 dedicated cables. That's completely fine. But because there's 3 connections here, don't feel super bad if you have to use 1 cable and then another shared connection off the same cable and then another dedicated cable. The fact that they're using 3 here means that they're pretty much guaranteed that that's always going to be the case, that you've got 2 runs back to the power supply. And so this card definitely needs more than 1 connector. More than 2 connectors, maybe with an overclock. Now for our test system, we're using the MSI Suprim X. This is a motherboard that comes with a built-in monoblock. It comes with a monoblock and everything that you need. I've only added here a pump, some fittings, and some flexible tubing, and a 360mm radiator in the front of our fractal design case. This is RGB to the max, but this system works really well. Now if you're thinking, hey, wait a minute, this looks exactly the same. That's because the heatsink and card configuration of the 3090 is almost identical to the Suprim X 3080 that we reviewed previously. The only difference here is that we've gone from 10 gigs of VRAM to 24 gigs of VRAM. And that extra VRAM is definitely something we can take advantage of when we're rendering things like Premiere videos. Now in Jensen's presentation, when they released the 3090, they kind of touted this as a Titan replacement. And in a lot of ways, it can be. I mean, for content creators and people that need a lot of VRAM, people that are doing rendering with things like Blender or, more sort of like prosumer, hobby, quasi-professional, having 24 gigs of VRAM can make a big difference. And if you paid $3,000 for the Titan, and this card is only around, the MSI version of this card is a little more expensive, but, you're targeting a $1,500 to $2,000 price point. It's a premium card. The price difference for the performance in gaming, in my opinion, is not worth it. But most games don't use 24 gigs of VRAM anyway. Productivity is where the difference is. But there's also one kind of important difference in terms of the driver stack, and that is the Titan. You have to understand, that was an Nvidia only card. They didn't really share that with partners. There was no partner version of the Titan. There's a lot of nice partner versions of the 3090. The problem is that Nvidia didn't open up the driver fully. So the driver is not really at parity on the 3090 with the Titan. The Titan is a slower card overall for just about everything, but there's a few key workloads that you see come up in the spec benchmarks, and those are for more like professional applications. Things like architecture, AutoCAD, that kind of thing. And the driver pathway on the RTX is not as optimized as it is on the Titan, so the Titan ends up being faster, which is purely down to just software gimping of the drivers. So that's what you lose in the price difference from $1,500 to $1,000. Maybe Nvidia will do something like open that up with a software update or something like that. Overall though, I think that the reason that this card is only $1,500 to $2,000 versus $3,000 at the Titan is because of AMD. I think that if AMD hadn't had this ridiculously strong showing in terms of just raw GPU performance, I don't think the pricing would have been nearly this good on Team Green. That said, Team Green does actually have some really compelling features. The big one is DLSS. DLSS is kind of an upscaling technology. At the time I'm doing this video, AMD's comparable technology is not out yet. And what it does is it upscales, but it uses AI and some other special sauce to do the upscaling. So it's not actually clunky. The performance is kind of mind-blowing, and what you get when you do the upscale is kind of mind-blowing. It's legit an extremely impressive technology. I mean, it's kind of cheating because technically the game is only having to render the game, at a lower resolution, and then so it can take, like, say, a 1080p game and scale it up to 4K. But the fidelity of the 4K image is almost, if not exactly or close to the same as a natively rendered 4K title. So I don't know if it's really cheating. Like it legit, the performance and image quality is legit kind of mind-blowing. DLSS is a really impressive technology from Nvidia. And you only get that from Team Green. There are other technologies like RTX voice, which officially is only enabled for RTX cores, although you can actually enable that on non-RTX workloads. So like the Titan driver path, it's a little bit Nvidia shenanigans that are going on there, and it's something that they should maybe address, and maybe competition will force them to address that with what they're doing. And the experience so far with this card is also kind of mind-blowing in terms of game performance and that kind of thing. Got the Predator CG9, that's 120 Hz 4K monitor. It can go up to 144 Hz with display stream compression. That's through the level 1 KVM. That's the 4-port prototype. It's up for pre-order on store.level1text.com. You're welcome. But yeah, it's been an absolute joy to play with this card and play games and work on Cyberpunk 2077. Shh, not really. I didn't get an early copy, but yeah, Cyberpunk 2077, with the ray tracing. It's really good. Nvidia is also ahead of the game in terms of ray tracing. I mean, there's not a lot of games out there that support ray tracing, but if you're like super into ray traced Quake 2 or Minecraft, the performance is kind of mind-blowing in terms of like what it can do. Like, I never thought we would see ray tracing this good after only 2 or 3 generations, depending on how you count. So there's that. I mean, Quake 2 originally, when it came out, and the whole mouse look, well, Quake in general, and then Quake 2, when it came out, it was these like computer games. These are amazing. And the same computer game, just rendered a different way, is now even more amazing. It's really exciting. And again, it was a very nice gesture of MSI to send this over to congratulate us on the growth of our channel and that kind of thing. They didn't have to do that. I appreciate that. You know, no strings attached, obviously. So as we look at the gaming benchmarks and we look at the overall performance and the performance difference between the 3080 and the 3090, the 3090 does do a bit better at higher resolutions. It doesn't scale on the low end though. If you wanted 500 FPS at 1080p, no matter what GPU you have, even for future GPUs, you're going to be limited to the rest of the system. I mean, even Ryzen 5000, which is currently faster than what Intel has to offer with these games, you know, you don't see much scaling past, like in Tomb Raider, for example, past 200 FPS. That's just, you know, the engine starts to struggle. When we did the deep dive on GTA 5 a couple of years ago, that engine really tops out at about 140 FPS, and then after that, everything starts breaking. And we started having hardware that could easily deliver that. So if you extrapolate that pattern and you think about, it's like, what is the human eyeball capable of seeing? VR is still pushing the envelope a little bit, but I think 4K is going to be it for a while. I think the innovations that we see in computer graphics are probably going to be around ray tracing and visual fidelity and more special effects and more types of special effects, and less about pushing the number of pixels. And I think that if it's not already happened, you're going to see a bifurcation of the GPU market. The 24 gigs of VRAM here and some of our machine learning benchmarks, yeah, it came in really, really handy. But there are other GPUs that are completely different silicon processes from completely different fabs that are better suited for machine learning. I mean, Ampere on TSMC's process is what we have in the data center. This is Samsung's process, so it's a different process, similar architecture, but it's already sort of different in terms of machine learning. And I think that that's inevitably the future, because the resolution of your eyeballs is not increasing. We don't have a direct brain interface. So the only thing that can be done to improve these GPUs is to make them require less power, make them produce less heat, to make them less expensive, and maybe to offer higher visual fidelity. But in terms of like pushing the number of pixels, it's not gonna get a lot better from here. This is pretty much it. So to be sure, the price is high, but the performance is also high. The performance is not high in line with the performance for gaming, but for productivity and things that will use VRAM and things that don't need the Titan driver path, which is not a huge swath of things, but is certain things, then this card can make a lot of sense. If you run a YouTube channel and you do, you know, Premiere and After Effects rendering with a fair number of effects, 24 gigs of VRAM at this price point is pretty darn good. I mean, the whole reason that I bought some other GPUs that have 16 gigs of VRAM, which was a lot at the time, was strictly because of the VRAM and because everything ran really well with a lot of special effects with a lot of VRAM. If you look at things like Puget Bench, you know, having a GPU for Photoshop is better than no GPU, but beyond that, it doesn't really matter. If you look at things like Premiere and After Effects, there's really not a lot of difference. It starts to become project specific, and you can't really talk about it in generic terms. So if you are doing something that requires you know, a lot of special effects, or you're doing something like, you know, Octane Renderer, which really benefits from 24 gigs of GDDR6 here, then yeah, it can make sense financially. But for gaming, the 3080. The 3080 is the flagship GPU, and that is what Nvidia told us. And that makes sense, because that is the GPU you should buy for flagship gaming. You're not going to be gaming at 8K, you're not really losing anything in gaming, but it is nice to have the horsepower. I have to admit that. I'm Wendell, this is Level 1. I'm going to go enjoy some more Cyberpunk, probably, unless I'm frustrated with it, with the 3090. Thank you, MSI, again. Most gracious. I appreciate it. Here's to 1 million, I guess. Thank you. Thank you to our supporters on Patreon and Float Plane and all of that. Thank you. Bye. Hello.